In this video, instead of getting a single fraction in the numerator and a single fraction in the denominator, what we do is we look at the denominators of all of the fractions and find the LCD of all of them at one time. Then multiply the fractions in the numerator and the fractions in the denominator by the LCD, clearing it all the fractions at one time. So, looking at this first example, I have a whole number, which I could put over 1. I have an x squared, x, and an x squared. So LCD is the highest exponent we see of all the factors, which would be x squared. So instead of getting a single fraction again, I just take that LCD, multiply it in the numerator, multiply it in the denominator. X squared times all of this in the numerator, x squared times all of it in the denominator. I have to be sure to distribute to everything. So x squared times 1 is just x squared. X squared times the 25 over x squared, so right here, x squared times this term. Let's just write it out for a second. X squared times 25 over x squared. So the whole reason we did this is that the fractions should divide out. X squared divided by x squared is 1. And I'm only left with the 25. So minus 25. In the denominator, same thing. I'm taking that x squared and distributing it. So I would have x squared times 7 over x. In this case, one of the x's divide out. I still have another one. So 7x is left. Plus that x squared times the 35 over x squared. The x squareds divide out, and we're only left with 35. So we have cleared out all of the fractions in one go. After we've gotten rid of all those fractions, we factor and divide out any common factors. In the numerator here, I have a difference of squares, so I can factor those into conjugates. X plus 5, x minus 5. In the denominator, I'm taking out the GCF of 7. I would be left with x plus 5. I look for common factors. I see x plus 5 divided by x plus 5 is 1. So at the end of the day, I have x minus 5 all over 7. And that is as far as we can go. Go ahead and try this next example here. Alright, let's see how you did. So we've taken into account the denominators of all the fractions from the fractions in the numerator and the fractions in the denominator. We see that they already have a common denominator of x plus 2, so that's our LCD. X plus 2. We take everything in the numerator times x plus 2 and everything in the denominator times x plus 2. And we distribute it to both terms. So in the numerator, I would have 8 times x plus 2, and then the 5 over x plus 2 times the x plus 2 will divide out, and we would be left with just the 5. Alright, so that was this one here. 5 over x plus 2 times the x plus 2. The whole reason we divide by or multiply by that LCD is the denominators divide out. Then the fractions in the denominator, that 4x over x plus 2 times x plus 2. Again, the denominator divides out, and we only have 4x. And then we have that negative 7 times x plus 2 as well. So this one here. Now I'm going to simplify everything. So I'm going to distribute the 8, distribute the 7. I will have 8x plus 16 minus 5, and then 4x minus 7x minus 14. I combine my like terms. Positive 16 minus 5 is positive 11. And then 4x minus 7x is a negative 3x minus 14. I look for any common denominator or common factors. I don't see anything. There's no difference of squares or anything like that. This is as far as we can go. And that's the second method. So you may choose the first method or second method. There's pros and cons to both. If it's easy to get the common denominator for all the fractions, usually I'll use the second method. But if they have totally different common denominators, then I tend to use the first method.